All right, hey guys. So this is going to be the video answer key for. Gosh, why won't that go away? You there? Go away. This is going to be the video answer key um, for for page one of your second day of the review. So you're looking for problem two, example one. So this says Indiana Jones is running and then jumps straight off a cliff. So he's running along and he jumps straight off a cliff. Cool. Don't write that. Um, Now it says draw a force diagram. Force diagram for Indiana while he's running. Now I know that lately we've been doing force diagrams without the drawing, but for this one we're going to go ahead and do the drawing. So there's a couple of things happening here. Remember, for a force diagram, we want to identify all the forces. So let's look at touch forces first. So what forces are acting on Indiana? Well, I know that because he's touching the ground, there has to be a normal force going straight up. Okay, whoops, what? No, don't write in. Fn, and that's caused by the ground. Okay, now he's also got friction acting on him from the ground. Because we know that anytime there's motion, there's also friction resisting that motion. So if he's moving, there's got to be friction working against him. And now the other thing here, so those are our touch forces. So the ground is the only thing touching Indiana. So those are the only forces acting on him from touch. But we know that there's a field force, a non-touch force that's always acting as long as we're on Earth, and that's got to be Fg. That's gravity, and gravity comes from the Earth. So I know there's going to be a lot of people that want to write the word gravity right here. Don't write gravity in your parentheses. Remember, you're writing the agent, the thing that's causing the gravity, which is the Earth. Okay, so let's go over and look at B. Now draw a force diagram for Indiana just after he jumps off the cliff. Now, remember, anytime something's in the air, the only force is gravity. If it's in the air, the only force is gravity. Write that down on your card right now. If it's in the air, the only force is gravity. So there's no touch forces. The only force we have is gravity straight down. Now, a lot of people are going to want to put forces going this way or maybe going this way. I don't know. But we don't want any of those. All we want is gravity. Now, over here, this is a little bit weird. Draw a force diagram for Indiana Jones right before it hits the ground. So, realistically, there's no reason why it's any different than this one. He's still in the air. It's still the exact same force acting on him. So, it's the exact same gravity, Fg, caused by the Earth. Okay, so that should be nice and easy for us. All right, now we have some calculations. Let's look at problem number 3, example 1. Mr. McSparron drops a watermelon off the top of the school. He times the fall and finds that it takes the watermelon 1.1 seconds to hit the ground. And then it wants us to calculate the height of the school. So remember our steps. And if you guys have a problem, if you guys have a hard time, write these steps down on your card, okay? So step 1, write it down on your card. Step 1 is to identify what they gave you. So they gave me 1.1 seconds. Well, when I look up on the board, I'm going to see that 1.1 seconds, if it's listed in seconds, that means it has to be delta t. So my delta t is 1.1. Now, they don't give me anything else, but I can decide on what I'm looking for. So step 2, identify what you're looking for. In this, it's asking me to calculate the height. So the height, when I look up on the board, is yi. So that's enough for me to go ahead and solve for yi. Because if I look, no, one more thing. Remember, if I drop something, the initial velocity is 0. Starts off going 0. So if I look up on the board, I know delta t, I know vi, I don't know yi, so let's use the yi equation from the board. Remember, this is the one on the left side of the board. So it's going to be yi equals 4.9 delta t squared minus vi delta t. And now we can go ahead and plug in, okay? So 1.1 is going to go in place of delta t. 0 is going to go in place of VI. And 1.1 is also going to go in place of that delta t. So I'm going to end up with yi equals 4.9 times 1.1 squared minus 0 times 1.1. Now remember, the very first thing that we should see here is that 0 cancels all this out, because 0 times 1.1 is just 0, so that goes away. So now I'm left with this 4.9 times 1.1 squared. So I'm going to go ahead and do this on my calculator. 1.1 squared is 1.21. So yi equals 4.9 times 1.21. And I'm going to get 5.93. 5.93. And we always need a unit. Don't forget your units. Meters. There we go. There's the answer to that one. Now, calculate the velocity of the watermelon just before it hits the ground. So again, step 1, write your knowns. Write what they gave you. Delta t is 1.1. Yi, I now know that that is 5.93. And Vi is still 0. Okay, so now I want to calculate the velocity just before it hits the ground so I can use that very top equation. Oh, wait, let's do this. So, number 2, it wants me to calculate velocity. I've got Vi and Vf. Now, I already know Vi. That should give me a hint that Vf is going to be my question mark. If you are still worried about which one it is, remember that just before it hits the ground tells me that it's at the end of the motion. It's not at the beginning of the motion. So the end of the motion means Vf, velocity final. All right, so I'm going to use this. Vf equals Vi minus 9.8 delta t. Okay, and now I can just plug in. 1.1 is going to go there. 0 is going to go there. I don't need yi for this, so I can ignore it. So I'm going to end up with Vf equals 0 minus 9.8 times 1.1. So let me do 9.8 times 1.1, and I get 10.78. So Vf equals, negative 10.78. Don't forget the freaking negative. Write it on your card. Make a note. Don't forget the negative. All right, and that is meters per second. There we go. Now go on and try the next part on your own.